Right, so you've been working with groups in Python, right? Like bundling data together and all that. Super handy for keeping your code organized. But today we're diving into something totally different, something that can make your programs feel, well, more alive.
Yeah, we're talking about making things dynamic, things that change and evolve, even when you're not like clicking buttons or typing. And we're going to explore this through the idea of step events.
Step events, yeah.
Yeah.
Basically, they let your program do stuff automatically, kind of like it has its own internal clock ticking away behind the scenes.
Exactly. And to really get into this, we're going to be looking at some material from CMU CS Academy. They've got some great explanations about how step events work and how you can use them, especially for things like animation.
Which is really cool.
Yeah.
I mean, think about it. Animation is all about creating the illusion of movement, right?
Mm.
And step events are a key ingredient in making that happen. But first things first, what are these step events all about?
At the heart of it all is a function called onStep.
On step. Okay. Now, I remember learning about other functions like on mouse press and on key hold, right? These are all ways to make things happen in your program, but on step seems different.
It is. You see, with on mouse press or on key hold, something only happens when you do something specific, like click the mouse or press a key. On step is different. It gets called repeatedly all on its own as time passes.
So it's not waiting for me to do anything. It's just happening in the background
It-
automatically.
Exactly. And that's what makes it so powerful for creating dynamic behavior. The CMU material starts with a very simple example to illustrate this.
Oh, yeah, they use the counter, right?
They do. You start with a label on the screen, just showing the number 0. Then they define a little function .def on step, .counter.value plus at 1.
Okay, so every time onStep gets called, it takes the value of the counter and adds 1 to it. And because onStep is running constantly.
The number on the screen just keeps going up. 1, 2, 3, 4, and so on, all by itself. No clicks, no key presses, nothing.
That's pretty neat. And it all comes down to the fact that onStep is happening automatically over and over again. But how does this connect to animation? Because I know that's where things get really interesting.
Well, imagine instead of just increasing a number, you're changing something visual on the screen. Like, let's say, the position of a shape, or its size, or its color. If you do that repeatedly and quickly enough, it creates the illusion of movement.
Ah, I see. And the example they give is a rotating star, right?
Right. First, they create the star.
Something like star 200, 200, 100, 5, fill gold, if I remember correctly.
Exactly. So picture that. A nice gold star right in the middle of your screen. Then they define another onStep function.
This time it says def onStep.
Right.
dstar.rotateAngle plus 1.
So instead of changing a number directly, it's changing a property of the star, specifically its rotate angle. And what happens?
Well, since onStep keeps running, each time it runs, the star's rotation angle increases by 1 tiny little bit, making it look like it's spinning smoothly.
Precisely. And the source material even throws in a little challenge. What happens if you change that plus sign to a minus sign in the onStep function?
Oh, yeah, I remember that. They
Yeah.
say the star will rotate in the opposite direction, counterclockwise.
It's a really subtle change in the code, but it has a big effect on what you see. And it all goes back to how variables work, how that plus or minus changes whether the angle is increasing or decreasing.
It's a good reminder of those fundamentals. But okay, so we got this rotating star. How do we control how fast or slow it spins? I mean, onStep is happening automatically, but is there a way to like speed it up or slow it down?
There is. And the CMU material introduces a concept called app.steps per second to do just that. By default, onStep gets called 30 times every second.
30 times a second. Wow, so it's happening really fast.
It is, but you can change that number using app.steps per second. And they've got a fun interactive example with keyboard controls.
Yeah, you can press F to make it faster and get
Yeah.
back to normal, and S is to slow things down.
Exactly. So imagine you're running the program, the star is spinning, you press F, and suddenly it's zipping around. And all that's changed is how often onStep is being called.
So the code inside onStep, the star.rotateAngle plus opal 1 part, stays the same.
Exactly. The star is still rotating by the same amount each time, but it's happening more frequently, making it look much faster. Press and it goes back to a slow crawl because now onStep is only running a few times per second.
I'm starting to see how much control you have over these step events. And they even have another example with gears, right?
Yeah, the gears example is great because it shows how you can have multiple things happening at different speeds. Each gear is rotating, but some are spinning faster, some slower, some even in the opposite direction.
And it's all controlled by how much you change the rotate angle of each gear within the onStep function.
Right, and they even tie it back to app.steps per second. You can press the up arrow key, and it doubles the value of app.steps per second.
So everything speeds up. That's really cool. But there was one last thing mentioned in the material, on steps in, and I wasn't quite sure what that was all about.
OnSteps N is kind of a specialized tool. It lets you manually trigger a bunch of OnStep calls all at once, like N times in a row.
Ah, okay. So if you need to simulate a certain number of steps happening quickly, you can use that.
Exactly. They mentioned it's often used for testing your code, so you don't have to wait for real time to pass if you just want to see what happens after a certain number of steps.
Makes sense. So, big picture, what's the key takeaway from all of this about step events?
I think the main thing to grasp is that OnStep allows you to introduce a sense of time and change into your programs. You're not just reacting to user input, you're creating things that evolve and behave dynamically on their own.
And by combining OnStep with app.steps per second, you've got incredible control over the speed and rhythm of those changes.
It really opens up a world of possibilities. Think about it. You can make things move across the screen, spin, change colors, grow, or shrink. Anything you can control with code can be linked to a step event.
It's like you're giving your programs a heartbeat, a way to exist and change over time. And this is just scratching the surface. What other creative ways can you imagine using step events?
Oh, the possibilities are endless. Could you create more complex animations, maybe simulate the physics of objects moving and interacting, or even build the core logic for simple games where things happen automatically?
So much to explore. I'm really excited to see what you all come up with using these concepts. Step events are a powerful tool for bringing your Python programs to life, and we encourage you to experiment, have fun, and see what amazing things you can create. Thanks for joining us for this deep dive.